Hello students. In the previous video, we learnt about this quadratic formula which says x is equal to minus b plus or minus under root b square minus 4ac upon 2a, where x is the variable of the given quadratic equation ax square plus bx plus c is equal to 0. This formula can also be written as x1, which is equal to one value of equation, which is alpha, which is equal to minus b plus under root b square minus 4ac upon 2a, and x2, which is the second value of variable, which is equal to beta, which in turn is equal to minus b minus under root b square minus 4ac upon 2a. This is because we know that quadratic equation is having degree 2 and it has two roots, which is alpha and beta. Now students, pause the video. Now students, can you observe a term which is present under the square root? Yes, it is b square minus 4ac. This term is called as discriminant. It helps us to decide nature of roots without even actually finding the roots. We will study this in our next video. For now, let us solve one example to understand use of this quadratic formula. For example, a rectangular park is to be designed whose breadth is 3 meters less than its length. Its area is to be 4 meters square more than the area of a park that has already been made in the shape of an isosceles triangle, with its base as the breadth of the rectangular park and altitude of 12 meters. Find the length and the breadth of the rectangular park. So students, here we are asked to find out length and breadth of newly designed rectangular park. So for that, let us assume breadth of a park x meter. And since we are given that breadth of park is 3 meters less than its length, or we can say length is 3 meters more than the breadth. So therefore length of the park will be x plus 3 meters. We know that area of rectangle is L into b meter square. Therefore area of rectangular park is x into bracket x plus 3, which is x square plus 3x meter square. We are also given that there is another already existing park which is in shape of isosceles triangle, and base of this triangle is same as breadth of rectangle. Therefore, base of triangle is equal to breadth of rectangular park, which is equal to x meter. We also have information that altitude of this park is 12 meters. Students, recall that altitude is a perpendicular line drawn from vertex of a triangle to the opposite side or base of that triangle. This gives us the height of that triangle. Therefore, height of triangular park h is 12 meters. Now we already know that area of triangle is half into base into height, and therefore area of our park is equal to half into x into 12, which is equal to 12x upon 2, which comes out to be 6x meter square. Now we are given a relation that area of rectangular park is 4 meters square more than area of triangular park. Therefore, our equation becomes x square plus 3x, which is area of rectangular park, equal to 4 plus area of rectangular park, which is 6x. Therefore, x square minus 3x minus 4 is equal to 0. Now using quadratic formula, x equal to minus b plus or minus under root b square minus 4ac upon 2a, we can get values of x, which will be the roots of this equation, and in turn length and breadth of the rectangular park. Now students, compare this x square minus 3x minus 4 equal to 0 with our standard quadratic equation ax square plus bx plus c equal to 0. And from there we get value of a as 1, value of b as minus 3 and value of c as minus 4. Now putting all these values in our quadratic equation and solving, we get one value of x as plus 4 and the other value of x as minus 1. So I can say one root alpha is equal to 4 and the other root beta is equal to minus 1. Now students, you can observe that one of the root is negative and length of the path can never be negative. Therefore, x equal to minus 1 is not a valid solution. Therefore, breadth of path, which is equal to x meters, is 4 meters. Now putting this in our expression for length of the path, we get x plus 3 equal to 4 plus 3, which is 7 meters. So therefore, length and breadth of rectangular path is 4 meters and 3 meters respectively. So students, now we have seen how we can directly use this formula and find out the roots or the solutions of quadratic equation. In the next video, we will learn about discriminant d of quadratic equation and how it helps in deciding nature of roots.